Let's talk about nuclear energy. Nuclear power is another non-renewable energy resource used to generate much of the world's electricity. Nuclear energy provides 20% of the electricity in the United States. Inside a nuclear power plant, controlled nuclear fission, F-I-S-S-I-O-N, reactions occur. Nuclear fission is when you split an atom's nucleus into two. When you do that, when you do fission, a great deal of energy is released. This energy is used to heat water and turn it into steam. The steam then pushes up and turns the blade of a turbine and produces electricity. So we're using the heat from the fission of the energy to produce steam and to turn a turbine. Okay. So, select all that apply from this paragraph about nuclear fission. It burns atoms to make CO2. It fuses atoms' nucleus. It heats water into steam. It's a non-renewable resource. It's a renewable resource. It produces 20% of the U.S.'s energy. It splits an atom's nucleus. Which ones of those are true? Right? It heats water into steam, right? It is a non-renewable resource. It produces 20% of the U.S.'s energy, and it splits the atom's nucleus. Those are all true about nuclear fission. Uranium is the fuel used for nuclear fission. Inside nuclear reactors, it is a heavy metal that occurs in most rocks and is usually extracted through mining. Uranium is found on Earth, was part of the original cloud of gas and dust from which our solar system was formed. Uranium is found throughout the Earth's crust, but large ores of the material are formed from geological processes that only occur in certain locations on Earth. See Figure 7. Right? The fuel for nuclear fission is called fissile, coal, electricity, or uranium. Right? The fuel for nuclear fission is generally uranium. Now there's been some recent advancements using thorium, but in general, currently we're using uranium. Distribution of uranium around the world. According to the World Nuclear Association, almost 70% of accessible uranium is found in only 5 countries. Okay? Circle the 2 countries with the greatest percentage of uranium resources, and what patterns do you observe in the distribution of uranium? Let's investigate those. So we're going to start by circling the 2 countries with the greatest percentage of uranium resources. Which 2? Right? That's going to be Australia and Kazakhstan, right? Australia with 29% and Kazakhstan with 13%. So overall, these 2 countries control 42% of all the uranium, all the nuclear supplies that the world needs for nuclear fission are contained in those 2 countries. If we look at the patterns of distribution of uranium, what do you notice? Is it evenly distributed? Is it unevenly distributed? What else do you notice? Okay, so our questions are, is it evenly distributed? Is it not evenly distributed? Some areas don't have any. There's lots in the USA. There isn't much in the USA. Which of those are true statements? Okay. It's not evenly distributed, right? Australia and Kazakhstan have a lot more than a lot of the rest of the world. Some areas don't have any, right? There's lots of areas where there is no uranium. Look at the oceans. There's none in the oceans, interestingly. And there isn't much in the United States. So the United States is actually pretty poor when it comes to uranium supplies.